Okay, we're actually picking up with your worksheet 10-4 intro that you did for homework, and we're going to see how we can relate that to the new section, section 10-4. So I'm starting with the three pictures at the top. We should have had inscribed polygons in our circles. And I want to focus on a transition from talking about an inscribed polygon to talking about any one of these angles. And since it's an inscribed polygon, they have a vertex on the circle. We're going to call those inscribed angles. So we're now focusing on inscribed angles, ignore the rest of the polygon, and we're going to talk about how we know the measure of that angle. Up until now, we've only talked about central angles. So let's jump down to the second one here. And in the second section, number 4, we should have said angle 1 was 80 degrees because our arc was 80, so our angle was 80. Okay, that was prior to today. Now, we're going to talk about this angle, angle 2, and figure out how does that actually compare to my arc BC here. And you're going to find out it's not the same. Now, if you did this correctly, you should have used, of course, supplementary angles here to get 100 for this angle. And then if you're really observant, you should be able to observe that that triangle ABD is an isosceles triangle. That's the trick there, because we have two radii. You're used to seeing the radii. Radii are congruent, and that gives me equal angles, 40 degrees and 40 degrees, to add up to 180 for the triangle. Now, my observation that I want you to make is we've got 40 degrees for our angle, and our arc was 80 degrees. What's the relationship there? It appears that the angle is half the arc. But before we assume that, let's do another example. Going backwards on this one, you should have been able to get that if we start with angle 2 is 15 degrees, and we work our way out of this one, go ahead and try it on your own, again, using the isosceles triangle, and see what you come up with. I came up with an arc of 30 degrees, and therefore also a central angle measure of 30 degrees. But again, let's focus on, instead of focusing on the central angle measure, let's focus on the angle and the arc. So hopefully I've convinced you a little bit, I know we didn't go through the two-column proof, that an inscribed angle, vertex on the circle, has a measure that's equal to half of what we call the intercepted arc. That's the part of the circle that the angle is literally cutting off. Grab your circle wheel, and we're going to put this on there. It's the first theorem that we're going to put on. This is theorem 10-6. Again, we're in section 10-4 of your textbook. And in the first section, I want you to draw a circle. You may have to pause the video and get some circles on there. I did a little bit ahead of time here. And let's go ahead and put an inscribed angle on the circle. Inscribed angle because my vertex is on the circle. Key point here. And I'm going to go ahead and throw a few letters on here. Relationship is that the measure of angle ABC is equal to 1/2 the measure of arc AC. And of course, if you phrase that the other way, we can pretty easily get measure of angle ABC times 2 is equal to the arc. The angle's half the arc is twice the angle. Again, we're talking inscribed angle here and the intercepted arc. The other 4 theorems that we're going to establish are all just variations of that. So I'm going to go through them pretty quickly. Follow along. You can watch and then write down. Pause the video as you need to. In the second one, I'm going to start with a simple picture similar to what we just had of an inscribed angle. And without doing a ton of extra stuff here, let's call that angle A. And we can agree that angle A is equal to half of the intercepted arc across the circle. Now, if I throw another inscribed angle in there, and just for the sake of discussion, we'll call that B. What can you tell me about B compared to A? Angle B compared to angle A. And if you look closely, angle B is going to be half of the intercepted arc. But wait a second, that's the same arc as the arc for angle A. And therefore, you should be seeing that angle A is actually going to be congruent to angle B. And of course, I could throw another one in there, just for fun, let's put an angle C over here. And again, angle C, half of its intercepted arc. They all have the same intercepted arc. When we have angles with congruent or with the same intercepted arc, they will be congruent to each other. Angle A is congruent to angle B, is congruent to angle C, etc. As many angles as we have. For a name for this one, I'm going to call it same intercepted arc. Again, variation of just my basic inscribed angle theorem. One more variation. This one I want you to draw a semicircle. So, or I guess two semicircles. So I'm splitting my circle into two parts. I'm going to note that we're given circle A here. So I do know A is the center. And then I want you to draw an inscribed angle such that the intercepted arc is actually one of the semicircles. And that just means that it goes to either end point of the diameter. And if we talk about that angle up there, whoops, I guess I shouldn't use A. Let's call that angle B. My question to you is, what do you know about angle B? And first, you should be telling me angle B is an inscribed angle because the vertex is on the circle. And then if you follow it out, you should notice that the arc for angle B is a semicircle, and therefore 180 degrees. An inscribed angle is half the arc, therefore half of 180 gives me a 90-degree angle, and you're seeing a right triangle. Absolutely. Every time you have an inscribed angle in a semicircle, it's going to be a right angle. And that was my best attempt to write inscribed semicircle for the name of that one. Theorem 10.8. 10.9 is going to take a little bit more thought. This one's not quite as intuitive as the other one. So I'm going to take you through a little proof. But go ahead and draw in your picture, go ahead and draw an inscribed quadrilateral. Try not to make it look like a square just because I want you to know it works when it's not a square. So some kind of irregular quadrilateral. Okay, you don't need to write anything else on your circle wheel. Just follow along. We're going to do a quick example. I'm going to give you one number to start with. So we're going to start with 100 degrees for that angle right there. Okay, inscribed angle. So if you follow the inscribed angle out, I want you to tell me what would the measure of this arc be. And hopefully you're doubling the 100 and saying that's going to be 200 degrees. Okay. My next question is, what's the measure of this arc? And hopefully you're recognizing, hey, that's the rest of the circle there. 360 minus 200 is giving me 160 degrees for that arc. And my next question is, what's the measure of that angle over there? And that matches up with my green intercepted arc, but it's an inscribed angle, so I'm going to take half of it, and I'm getting 80 degrees. Let's generalize the process. We're going to take away the numbers, and we're going to put in variables. So we're going to go back here, and instead of calling this 100 degrees, we're going to call this x degrees. So if that's x degrees, the next thing we did is we found the arc across from it, this blue one, and we said that that was double our angle, so therefore I'm going to say that's 2x. Good so far? How did we find the next arc? I'm over here at the 160, and we did 360 minus 200, but now my 200 is 2x, so I'm going to say that this is 360 minus 2x degrees for my green arc I've got. And the last thing I want you to do is tell me what would this angle be instead of 80 degrees. Well, how did I find it? I cut 160 in half to get 80. Now I'm going to cut 360 minus 2x in half. 360 minus 2x in half, or divided by 2. Let's divide both parts. 360 divided by 2 is 180. 2x divided by 2 is x. And I'm going to propose that that angle is really 180 minus x. Okay, I know that was a bit of algebra. What's the relationship between my two angles, what I would call opposite angles in my quadrilateral? My x right here and my 180 minus x. And hopefully you're seeing that those two angles are always going to add up to 180 degrees, and therefore we're going to say they're supplementary. If you totally lost me on the algebra, go back to the 100 degrees and the 80 degrees. Clearly supplementary. Start with any other number, try a different number than 100, start with 110 or whatever you want, try it again, and you should get that they always come out to be supplementary. So that is my relationship that I have in an inscribed quadrilateral. Let's go ahead and put that on our circle wheel. Now I want you to draw along with me. Probably the easiest way to mark this is to put some letters on here. So I'm going to do quadrilateral A, B, C, D, and then I'm going to put a couple equations. A plus angle C is what I meant to write. And angle B plus angle D is equal to 180 degrees. Inscribed quadrilateral. Okay, thanks for bearing with me. We're almost done. We've got one more. Notice I jumped numbers. This one's actually not in section 10.4. I believe it's in section 10.6, but we're doing it because it's still an inscribed angle. This time we're going to draw an inscribed angle, but instead of using two chords, we're going to use a chord and a tangent line, is what I was trying to draw there. And it's still going to make an inscribed angle because look at my vertex point. My vertex of my angle, here's my angle, vertex is on the circle. Good news, the relationship is the same. In fact, this one could have gone after our very first one because we're going to write almost the exact same thing here. Angle ABC is 1/2 of the intercepted arc. So the measure of angle ABC equals 1/2. Just be careful here. The arc is not AC. The arc is actually AB. It goes all the way to the vertex of the angle when you're looking inside that angle. Okay, again, think the part of the circle that the angle is cutting off. For a name for this one, I'm going to call it inscribed with tangent. And the only thing different between this one and the very first one I did is that this one looks different. It tends to mess with people a little bit. They have a harder time seeing it. But simple relationship, the angle is half the arc. That concludes the notes. Thanks for watching the video and filling in your circle wheel. This should get you through the homework in section 10.4 and allow you to work with inscribed angles pretty well.